Hello my friends, welcome to my channel. Talking to Israel, your teacher from Brazil. On this video, I'd like to speak with you about an exercise that a student of mine brought me. We solved it together and I thought it was going to be interesting to show to you guys, okay? It is about the determinant of a matrix. Okay, but we don't just want the determinant of this matrix. The exercise wants the determinant of the inverse of this matrix here. So how can we calculate that? We are going to use a property, okay? And I'm going to show you to you real quick. All right, we can use a property here. This is what we're going to do, and we can also try to invert this matrix here and find the inverse matrix and only then calculate the determinant. But I can guarantee you this is going to be a lot harder. The technique that we're going to use here is going to be a lot simpler, okay? So what the exercise wants us to calculate is the determinant of the inverse matrix of A. This is what we are going to calculate. But first of all, instead of inverting this matrix here and only then calculating the determinant, what we're going to do is to use this property here, okay? The property that we are going to use is this, that says that the determinant of the inverse matrix is equal to the inverse of the determinant of matrix A. All right, then this is going to facilitate our calculus. All right, my friends, I think that everybody knows how to calculate the determinant of this matrix here. The rule that we are going to use, it's called Sarri rule, and we simply copy this column here. Okay, sin x, and sin x, and we copy this column here. Cosine squared x, cosine x, and 1. Alright, and then what we do, we multiply like this. Multiply here, we multiply here, and we multiply here, and we multiply here, here, and here. Okay, these guys here that are the secondary diagonal of the matrix, we are going to put a negative sign to them, okay? So it's going to be the determinant of A is going to be negative. The multiplication of these guys here is going to be sin x times cosine x, sin x times cosine x, plus this guy here, we don't need to represent them because it is 0, okay? 1 times 0 is 0 times the sign is simply 0, okay? We are not going to represent them. And these guys here will be 1 times sin x times cosine x squared, but negative, okay? Negative sin x times the cosine squared x. Okay, now we are going to represent the positive people. The positive people will be sin x times cosine x times 1 is simply sin x times cosine x. Yes, this guy here we don't need to worry about because there is a 0 here. If we multiply by 0, we get a 0. And then here is going to be 1 times sin x times 1. It is simply sin x. Okay, we are almost there, my friends. Keep paying attention. Here we can say that we have negative sin x here and we have a positive sin x here. Okay, negative sin x cosine x, positive sin x cosine x. What we can do is simply cut this guy with this guy here, because negative this with positive this, it gets to 0. Then how about this guy here? Let's develop it. Okay, it's gonna be the cosine squared. We are going to put this like this, sine squared multiplying 1 minus sine squared of x, okay, plus this guy here, plus sine x. Okay, are you guys following? Are you understanding what I'm doing? Okay, I'm not going to write below here to enhance visualization for you to visualize better. I'm going to write up here, and you guys will understand exactly what I will be doing here. The determinant of A is going to be equal to this guy with this guy is simply negative sine x. This guy with this guy is going to be positive sine x. Sine x squared is going to be sine cubed of x. Sine x squared, sine x cubed. And then we have a positive sine x here. Okay, my friends, we are almost there. Keep paying attention. Okay, negative here with positive is simply cancel this. Then the determinant of A is equal to simply sine x cubed. And the inverse matrix, the determinant of the inverse matrix is going to simply be equal to the inverse of this. Okay, sine x cubed. And my friends, we've arrived at the solution of the problem that I wanted to show you guys. I hope you enjoyed the video. Goodbye.